Good day everyone, here's our math challenge for today. So let's start with a square with a side length of 10 centimeters. Next, let's draw a circle like this. Now the question is, what is the area of this blue shaded region, or simply the area of the circle? Now if you want to try this problem, just pause this video right now, and if you're ready, here's the solution. And I hope you pause this video. Now let's see if you got the correct answer. There's a lot of ways to answer this question, but on this video, we will use two concepts. The first one is the radius tangent theorem. It says that the radius of the circle and the tangent line to this circle must be perpendicular, or they create 90 degrees. Now the second concept is if we have a square and a triangle inside of it, then the radius of the circle must be equal to ABC divided by 4A, wherein A, B, and C are the side length of this triangle, and A must be the area of this triangle. Now let's prove this result very quick. Let's have a circle and a triangle inside of it. Next, let's name the vertices of the triangle as A, B, and C. Next, let's call angle BAC as theta. Now we know that the measure of inscribed angle is half the measure of its intercepted arc. Therefore, the measure of arc BC must be equal to 2 theta. Next, from the center of this circle, draw the radius directly to point B and point C. And let's call this radius as capital R. Now from the center, let's draw the radius that is perpendicular to this segment BC. Now it follows that segment BC is cut into two equal segments. And since it cuts into two equal segments, arc BC also cuts into two equal arcs. Therefore, this is theta and the other one is also theta. Now, according to central angle theorem, the central angle is equivalent to its intercepted arc. Since it is theta, this angle right here must be also theta. Now at this point, let's name the side of the triangle. So the opposite of vertex C, let's call this as small c. The opposite of vertex B will be small b. And the side opposite of vertex A must be side A. And since side A is cut in half, therefore this is A over 2 and the other one is A over 2. Now let's focus on this right triangle. We can relate the angle theta, A over 2, and R using sine function. Thus, we have sine theta equals A over 2, the side opposite of the angle theta, all over R, which is the hypotenuse. Now simplify, sine theta must be equal to A over 2R. Now let's focus to the area of the triangle ABC. Now we have a special formula to find the area of this triangle ABC given the two sides and an included angle. So the area of this triangle must be equal to 1/2 times B times C times the sine of the angle between side B and side C. Therefore, the area of this triangle ABC must be equal to 1/2 times B times C times sine theta. Now notice that sine theta is equivalent to A over 2R. So we can replace sine theta as A over 2R. Now simplify, 1/2 times B times C times A over 2R will give us ABC all over 4R. Now solve for R, we get that the value of R must be equal to ABC all over 4A, wherein A, B, and C are the side length of this triangle inside the circle, and this A is the area of the triangle. Now we will use this formula to find the radius of the circle. To do that, let's draw the diameter of the circle directly to the point of tangency of the circle and the square. Now take note that this diagonal is perpendicular to the side of the square because the side of the square is tangent to the circle. it directly follows that it cuts the side of the square into two equal parts. Therefore, this is 5 and the other segment is 5. Now, from the point of tangency, let's draw two line segments like this to create a triangle. Now, let's focus on this right triangle. We know that the base of this right triangle must be equal to the side of this square, which is equal to 10. Now, to find the length of the hypotenuse of this right triangle, we will use Pythagorean theorem. So we have c squared equals a squared plus b squared. Now, a squared represented by 5 and b squared must be 10. So we have 5 squared plus 10 squared. Now, 5 squared will give us 25. 10 squared will give us 100. Now, simplify. 5 squared plus 10 squared will give us 125. Now, square both sides to find c. We have c equals square root of 125. Now, square root of 125 is equivalent to 5 multiplied by square root of 5. Therefore, the hypotenuse of this right triangle must be equal to 5 multiplied by square root of 5. Therefore, the length of this segment right here is also 5 times square root of 5. Now, let's focus to the area of this triangle. And that's very easy because the area of this triangle must be equal to 1/2 times base times height. We know its base, we have 10, and we know its height is also 10. Therefore, the area of this triangle must be equal to 1/2 times 10 times 10. Now, 10 times 10 will give us 100, and 1/2 times 100 will give us 50. Therefore, the area of this triangle inside the circle must be equal to 50 square centimeters. Now, to find the radius of the circle, we will use this formula. We have r equals ABC, which is the side length of this triangle, all over 4 times the area of the triangle. We know all of these values, so let's substitute all of them. So the side length of this triangle must be equal to 10 times 5 times square root of 5 times 5 times square root of 5, all over 4 times the area of the triangle, which is equal to 50. Now simplify. 5 square root of 5 times 5 times square root of 5 will give us 125. Now cancel out factors of 10, and then cancel out factors of 5, and there you go, we have the length of the radius of the circle, which is equal to 25 over 4. Now take note that we can also use chord power theorem to solve for the value of r. But on this video, we use another method to find the radius of this big circle. Now at this point, we are now ready to find the area of the circle. And the area of the circle must be equal to pi r squared. And we know the value of r, or the radius of the circle, which is equal to 25 over 4. So we have pi multiplied by 25 over 4 quantity squared. Therefore, the area of the circle must be equal to 625 pi all over 16. Thus, the area of the region shaded in blue must be equal to 625 pi over 16 square centimeters. And as always, we're done.